But we also know that we should follow the directions, right? So what do the directions say on that? I'm looking at the 1-3 homework. And a few of you did absolutely magnificent, so I apologize to you that we are talking about this. But let's look at number 1, for example. It says, I am to use the average rate of change. Okay? So I am going to go ahead and find my differences. So over here, my differences are all 1. Those are called same sized input intervals, right? The interval between all the consecutive inputs is 1 long, or 1 wide, whatever. So this is 3, this is 5, this is 7, and this is 9. Right? So what are the average rates of change? These are the differences. The average rates of change would be this over this, this over this, this over this, and this over this. Is everybody clear on that? These are not the rates of change. These are the differences in the y values. The rate of change is going to be these over these. Now, since those are all 1, these will end up being the average rates of change. But initially, they are the differences. Are we clear on that? Okay, so let me look at my average rates of change now. It's going to be 3 over 1, 5 over 1, 7 over 1, and 9 over 1. Those are my average rates of change. Now, what is happening to my average rates of change? They are increasing by the same amount. So when that happens, when your average rate of change increases by the same amount, that's called a linear change. It's increasing by the same amount, it's quadratic. That is a quadratic characteristic. Okay, so what would have been a satisfactory answer? This data is quadratic because the average rates of change are increasing by a constant amount. Okay? Now, a couple of you, or a few of you, said, I am going to find, okay, so these are the average rates of change. These are the first differences. These are the second differences. When the second differences are the same, these are not a rate of change. These are the second difference in the y values. When those are the same, it's quadratic. If what? You cannot make a statement. You cannot write down a statement using second differences unless you have qualified what? Same size input intervals. If these numbers were all 2, but these weren't all the same, then you can't make a statement about second differences. Never make a statement about second differences unless you include a statement about same size input intervals. Okay, got it? But in this problem, we shouldn't even be talking about second differences because the directions tell us to use the average rate of change. Okay, we're following directions. All right, we'll do one more together. We'll look at the next one. All right, so let's see what's happening with the next one. All right, so I'm going to find my differences. This is 2, 1, 1, 2. Okay, so these aren't the same. That means I'm not going to be able to talk about first and second differences. I can talk about average rate of change. That's okay. That's what I'm supposed to be talking about anyway. So this is 2, this is 3, this is 1, this is 2. So what is my average rate of change? What are my average rates of change? 2 over 2, 3 over 1, 1 over 1, and 2 over 2. All right? Is it linear? Absolutely not, because these would all have to be the same. Is it quadratic? No, because this is 1 and 3, and this is 1 again. So this one is going up by 2, but then it turns around and goes down by 2, and then it stays the same? Okay, so what am I gonna say? It's not linear because the average rates of change aren't constant. It's not quadratic because the average rates of change are not changing by the same amount. Okay? Now, you guys are all smart people, and I know you have a sense, I hope anyway, you have a sense of what's happening, but you have to be able to verbalize it correctly, using correct vocabulary. And in this case, it's average rate of change and how it's changing. Okay, got it? Now, we're going to turn over to the back side. And this is a different question. It's kind of the same setup, but this says determine if it's concave up, concave down, or neither. All right, so let's go ahead and find our rates of change. So we have 2, 1, 2, 1, 3. So what are my average rates of change? 1 over 2, 3 over 1, 4 over 2. So my average rates of change are 1/2, 3, and 2. Would you agree with that? Now, those are all positive numbers, and that's great. What does that tell me about your curve? As I plot them, it's going up, right? These are like slopes, okay? I want to know about concavity, though. Concavity doesn't depend on sign. It depends on whether your rates of change are increasing or decreasing. So from 1/2 to 3 is an increase, but from 3 to 2 is a decrease. No, there's no concavity. Because if we were to be concave on that whole interval, they'd all be increasing or they'd all be decreasing. Okay, got it? What's an acceptable answer? We can't have a conversation about concavity here because the average rates of change are not consistently increasing or decreasing. Okay, we okay with that? All right, down there at number 3, down there we had a graph to look at. It says estimate the point of inflection. 2 things. First of all, it's an estimate. So the point of inflection is where the concavity changes. So if you've got something, that looks like this, we could argue till the cows come home about whether it's there or there. Okay, somewhere in there is where we change from being concave down to being concave up, right? But a point of inflection is a point. It's not x equals something, it's a point. So the point of inflection is a point. And then, what does that point tell me? Well, that is the place where the concavity changes. It goes from being concave down to being concave up. Got it? Okay. Anything else about homework you want to talk about? I'm talking about homework 1-1 to 1-3. If you turn it in, you have it back. So it's got marks on it or not. Oh, on 1.2, a lot of you have a comment on the back for number 3. I just said units. Rates of change have units. And my expectation of you was that you would know this is the projectile motion formula for an object with an initial velocity of 52 feet per second and an initial height of 6. I thought we talked about those back in chapter P. Did we talk about that in chapter P? So that's a projectile motion. Your unit would be feet per second. So all of your rates of change should have feet per second on them. you're describing how fast this object is traveling. Okay, so feet per second, your unit on that.
For other ones that are projectile motion, how do we know what?
You don't know.
Okay.
You don't know. So on the front side, the only one you knew was C. C had a unit. What was C?
Pounds per month.
Pounds per month. Yeah. If you just had a set of data, you don't know. All right. Anything else? On homework. All right. Let's get out that second review sheet. That other says review 2 on it. And this doesn't take a tremendous amount of time to get through, but I want to make sure that we get through at least one of everything. And then if we have more time, we can do more. You can come to the board and put some up or whatever. But let's go through and do at least one of everything. Okay, so we're looking at number 1. Somebody has drawn a graph. 5 points are labeled. There's no scale or axes, okay? The 2 points that we're concerned about are G and J. All right, are you looking at number 1? You following along here? Okay? So on this interval from G to J, which one of those statements is true? What do you think? G to J? So let's do this. Both parts are easy. If you put this on a coordinate axis system, it isn't, but you can do it. You can plot it on a coordinate axis system. Where would this curve be? Above the x-axis or below the x-axis? Above. And if a function is above the x-axis, it is considered positive. So it's positive. Now, on that little interval from G to J, are we increasing or decreasing? Decreasing. We have a negative slope. We're going down. So, the answer would be B. Everybody okay with that? Got it? Okay. What about part double I there? Describe how the rate of change is changing on that interval. How is the rate of change changing on that interval? Increasing. Why? Bingo. Did you hear her? She's dead on. If we're talking about how the rate of change is changing, we're talking about concavity. And that stretch from G to J is concave up. That means its rate of change is positive. Yep. Increasing. All right. Number 2. Rate of change is increasing. Concave up. The rate of change is increasing. All right, number 2. No, let's not do that. We did number 1. We'll come back and do that if we have time. Let's go to number 5. Number 5. So we've got this picture, all these points. On which of the intervals is F negative and increasing? So we want to be negative and increasing. So what do you think?
B.
B. look at from B to C, you guys. Are we going up or down? Up. And are those points below the x-axis? That makes them negative. All right, how about, all right, we did 5 together. All right, let's do 6, 7, and 8 right now on your own. Do 6, 7, and 8, see if you can figure it out. All relating to the same picture, and then we will compare answers. Tomorrow's quiz is going to have some multiple choice questions on it. Patrick, you okay? You got these done? Share your answers. Patrick, what'd you get for 6?
C.
Patrick got C for number 6. Are we in agreement with that? Oh, I see some shakes and some nods. Let's see. I am just gonna look at your answer. So from D to E, it says the rate of change is negative from D to E. What's another word for rate of change? Slope. What does negative slope mean? Going down? Are we going down from D to E? Yeah, I think he's right on. I think he's right on. Anybody have a question about that?
Or negative?
If you missed
The rate
it,
of change is
we
negative.
need to talk about it. All right, who has one to 7 you're willing to share? And answer the 7. Will?
I got A.
Will got A. Let's see, I'm just gonna check your answer. On the interval from A to B, the rate of change is decreasing. Now, from A to B, is the rate of change negative?
Yes.
Yes, but it is not decreasing because from A to B is concave up. Okay, so it's not A. All right, anybody have a different answer to 7? D, from E to F, from E to F, the rate of change is increasing. Yeah, because it's concave up. Yeah. And how about 8? Who's got an answer to 8? Annie? A? Or what am I doing? We're decreasing and concave up. So she says from A to B, we're going down and we're concave up. She's exactly right. All right? If you miss those, you need to spend a little more time on this. All right? Reading carefully. All right, let's look at 9 and 10. Another picture. On what intervals is H increasing? I think there's only one interval where it's increasing, and what would that interval be? -5 to -1. Yep, that's where it's increasing. On what intervals is it both positive and decreasing? So it's gotta be positive and going down. Charlie?
-1 to 2.
-1 to 2. think you're right on.
Would you ever do brackets? No.
Okay, there's always conversation about that. My own feeling is that at a particular point, you're not increasing or decreasing. So let's look at -1, for example. One side of -1 is increasing and one side of -1 is decreasing. So which interval are you gonna count it in? It can't be both, right? It's one or the other. So I just always make them open.
Okay.
So does, I don't know if you had Miss Ludington last year, so does she. She always leaves them open. All right. Okay, good for that. All right, let's go on, next page. Number 1 and number 3. Determine whether the variables have a positive rate of change or a negative rate of change. So in other words, if you graph it, are they going up or down? Are the points going up or down? The amount of money in a vending machine versus the number of items remaining inside the vending machine. Negative. More money, less stuff still in there, right? The number of years since 2000 versus the number of Teslas on the road. Positive. As time goes on, there are more and more Teslas, I guess. Okay, number 5. Number 5. You are asked to fill in this table, and you're given an equation. And there are different ways that you can do this. You're not told how to do it, you're just told fill in this thing. Alright, so what are your options? What are some different ways you can think of to do this? Well, could you literally plug in 0.5 and then plug in 0.8? Will that work? 100% that will work. What else could you do? So if that makes sense to you, that's how you're going to do it. What else could you do? Celeste?
Plug the equation into your calculator and then find.
And then, so like do value? Yeah. So if you type that equation in on your calculator, and then do second trace value and put 0.5, it will tell you that that is 0.45. And then you can second trace value 0.8, and it will do that for you. Okay? I got negative 0.456. Now there is a third way to do it. I'm not sure I would in this case because, well, we'll talk about why in a minute, but a third way to do it is to go, you have your equation already in, right? If you go to table, so it's above graph, second graph, it actually will generate a T-chart of points for you. Now, here's the thing. It will generate the T-chart on whatever intervals you want it to be. So to set up your table, you have to go to second table set, which is above window. And then you need to tell the calculator, where do you want the table to start? Well, for us, 0.5 is our beginning, so I would have my table start be 0.5. And then, this means, how big of steps do you want the table to take? Well, that's where it gets a little sticky with this one. If I did 0.1, that would be pretty easy. I could do all these, but to get these, I'm gonna have to have it be 0.01. And as soon as you make it 0.01, Then your table is going from 0.5 to 0.51 to 0.52. So you see, you're gonna have a ton of values. So if these were all tenths, I would use my table. But since they're not, I'll probably use value, probably go second half value. Okay, all right, we fill them all up, and then we're gonna find the average rates of change over the following intervals. So, I have not completed my table yet, but you're gonna fill all that in, or you would, fill all that in. And then if you wanted the average rate of change from 0.5 to 1.5, you would do G of 1.5, which, if you've already done your table, that's already filled in, that's out there, that's a number. And that would be your average rate of change on that interval. And then you would do whatever the next interval, the next one, the next one. Now notice, these two, what's the midpoint of 0.5 and 1.5? 1. Look at the next interval, what's the midpoint there? 1. But notice this one has a like radius or whatever of 0.5. The next one has a radius of 0.2, and then it's 0.1, and then it's 0.01. So what are we doing? We're squeezing in on 1. So you should be able to look at the numbers that you're getting, and they should be getting closer and closer to the instantaneous rate of change at 1. Okay? All right, you might want to take a minute sometime and try that. All right, let's see what else we got. Number 7. Circle the right answer. From point A to point B. Point A to point B. The rate of change is increasing concave up. Because because the graph is concave up. All right? From B to C. The graph of H. Kids, it doesn't say rate of change. It says the graph of H is increasing because the rate of change is positive. Look, from B to C, aren't we going up? So the rate of change is positive. That means the graph is increasing.
Wait, even if it's on the point of,
Yeah, that's the end of the interval. All right, from point C to point D, the rate of change, all right, C to D, the rate of change is decreasing because the graph is concave down. All right, next page. Number 1 and 2, right now. I want you to do 1, 2, and 4. Number 1, 2, and 4, right now do it. This is what we talked about in our homework. For each table of values, determine if the function could be linear, quadratic, or neither. So we're doing 1, 2, and 4. You got a thought? What's your thought?
Either because the rates of change are not the same for the other.
So neither, I agree with that 100%. What's my logic? The rates of change are not constant. And they aren't growing or changing by the same amount. There's a clear pattern in those rates of change, did you notice that? But it isn't linear or quadratic. We'll talk about it in unit 2. All right, how about number 2? Quadratic. Because what did you notice about your rates of change? They went from -3 to 0 to 3 to 6. So they are growing by the same amount? And how about number 4? Linear, because the rates of change are all the same, aren't they? All right, number 7, can you find K? Notice they tell you the function's quadratic, so you know it's quadratic. I want somebody to give me an answer and give me a reason. Leo,
Because the rate of change is decreasing by 2 every interval.
say that louder.
8, because the rate of change is decreasing by 2 at every interval.
Okay, did you notice that? That we're going down by 2 in every interval? Did you notice that? Okay, perfect. All right, last page. How about 11? Can you find K in 11? Notice for this table, you are linear. You are linear.
Yeah, so this is rate house, but that is like
Okay,
negative.
we're doing number 11.
So then this is -1, right? Your rate. So figure out this 5, 3, so another 2, or negative.
Wait, for number 7, how does it get 8? Because if it's going down by 2, it's going down by 1.
So then it has to be
The aggregate is
negative
only
1.
like that.
-1 half the word is change, the rate of change,
But you just said
like this change,
yeah, that was one.
like this change.
That part was one.
Okay, so for number 7,
We just know
Caitlin,
that it's
Yeah.
two
The
components, so -1 half
X
the-
intervals are all constant, right?
Yeah.
So I'm gonna look at just my Y values,
No.
all right? I'm looking at my Ys.
Yeah.
So how do I get from 0 to 5?
You go for 5,
And then I go from 5 to 8,
3.
go up 3. So 2 less.
Yeah.
And then I go from 8 to 9,
Yeah.
which is 1, so 2 less. All right, so I just went up 1.
Yeah.
I have to go up 2 less from that. So what's 2 less than 1?
-1.
So I'm going up -1. I'm at 9, going up
Yeah.
-1. So where am I?
8. Okay.
That's why the answer is 8. Yeah. Okay, now for number 11, it's linear. Anybody find a K there? 3? 3? Again, your X's are all evenly spaced, so you can make your statements based on what's happening with Y. And there we go. Everything's down 2. So it's down to 3. All right, 2 more, and then I'll shut up and you can go ahead and work with your partner. Let's look at 13 and 14. This time, we are determining if the function is concave up or down. Some of you in your homework drew a picture. Not acceptable. We're going to make our conclusion based on rate of change. All right, so do it. So for 13 and 14, determine if it's concave up or down. right, for 13, I got concave up. What about you? I got concave up because I looked at my average rate of change, and what did I notice about them? They're increasing. For number 14, I got concave down. Here are my average rates of change. Now, the average rates of change are all positive, and that's fine. But they're all getting smaller. They're decreasing, which means I am concave down. So if you were gonna draw this, since these are all positive, we are definitely going up, right? But because they're decreasing, we're concave down, so we're going up on an arc like that. All right, so we've gone through and did a little bit of everything. So now you have 15 minutes. You and your partner go back and redo some of the ones. I'll work on some of them and we'll compare answers. All right?